Now, as we go through, we want to start by deciding what our u is. That's going to be your innermost function. At least most of the time, it will be your innermost function. And then we want to let everything else, that's going to be the chain part, what's multiplied on, and that becomes our du. So as I work through this one, I want to let that innermost function, that x squared, be u. So we're going to let u equal x squared. I also need to figure out what du is. So du, taking its derivative, I'm going to do 2x, but I'm really using like implicit differentiation. I'm going to follow each of these derivatives of u with a dx. Now it's almost what we have up there in the integral, but notice I only circled the x and the dx. Right now I've got that 2, so I'm going to divide both sides by 2, and that gives me 1/2 du. We'll replace our x and our dx. So now we've got x squared replaced with u, and x dx is going to be replaced with our 1/2 du. I'm ready to take our integral and rewrite it in terms of u. The first thing that I want to do, though, let me actually get rid of that u just for a second. I want to rewrite the order of this. I'm going to rewrite it so it looks a lot more like a chain rule. So I've got the cosine of x squared, and then what's multiplied in is that x dx. Okay, so we're going to carefully replace each of these. That x squared is going to get replaced with a u, and that x dx gets replaced with a 1/2 du. So now replacing everything in terms of u, I end up with the integral of the cosine stays, x squared becomes u, and x dx gets replaced with a 1/2 du. Now as I work through, I can bring that 1/2 out in front, just working through my integral now, 1/2 integral of cosine u du. I can go ahead and take the integral of cosine. The integral of cosine is sine. So 1/2 sine of u, and I've got a plus c there, but this is not the form of the answer that I want. The form of the answer is going to have an x in it. So I'm going to go back to what my U-substitution was, and I had let u equal x squared. So I'm going to go back to x's, and I want to replace u with an x squared. Everything else will be in the right form for my answer. So I end up with a 1/2 sine of u, but that's x squared, and then plus a c. Here comes the next one. In this next one, we've got the integral of the natural log of x squared divided by x. Do you see that layering of functions? I want to still tackle this the same way by choosing my u, which is going to be that inner function natural log. And what's multiplied on the outside, in this case, part of it's divided, is going to be our du. So working that through, I'm going to have u be that innermost function, the natural log of x. I also need to take its derivative to find du. The derivative of the natural log of x is 1/x, and I'm going to follow that with a dx. So I want to rewrite that original integral so that the u-substitution is nice and easy. I've got the natural log of x squared, and then let's multiply on. I'm going to take that x out of the denominator and write it as 1/x multiplied, and then a dx. Now take a look at what we've got. This natural log of x, that's going to become our u, and the 1/x dx is our du, and I'm ready to make that substitution. So now, in terms of u, I get the integral of u squared, super nice, u squared, and that 1/x dx gets replaced with the du, and I'm left with a super nice integral. I'm going to go ahead and use my power rule for integrals. That power is going to go up to 3, and I'm going to multiply by the reciprocal 1/3. So I get 1/3 u cubed plus a c, but I need to go back in terms of x, and I know that u is equal to the natural log of x. So we're going to put that natural log of x right there. Let's do that final substitution now. Back to x land, I get 1/3 u cubed, but u is the natural log of x, and then I've got my plus c on the outside. This next one has a shortcut in it, and I want you to recognize the shortcut, but we do have the same steps. We want to choose u as the innermost function. Do you see what it is? If you guessed 4x minus 7, you've got it. You're doing fantastic. But take a look at what's multiplied on there. It's just a dx. So whenever you've got this case where you have just a dx on the outside, and I've got that nice linear function on the inside, you can take a shortcut. I'm going to show you what the U-substitution would look like, and then we'll do it a shorter way. So I know if I were to do a U-sub, you would be that innermost function, 4x minus 7, and I would also need its derivative du. That would give me a 4, and then I'm going to follow that with a dx. But remember that my integral only had the dx. So I need to divide both sides by that 4, I end up with 1/4 du replacing the dx. So take a look at that 1/4 that kind of popped out. It's the reciprocal of that coefficient. So when you've got that nice linear function in there and you've got just the dx on the end, you can take a really nice shortcut. I want to do the shortcut for sure. So I'm going to leave this in terms of x. So my integral is sine 4x minus 7 dx. As I take the integral of sine, I end up with a negative cosine. So I get negative cosine 4x minus 7. You can think of this actually as the opposite of a chain rule. So instead of multiplying the 4, I'm going to multiply a 1/4 out here on the end times a 1/4. And then I've got a plus c. This is actually my answer, but I want to make it look just a little bit nicer. Cosine of 4x minus 7 plus c. So watch for those linear functions as your innermost function so you can use just a reciprocal out in front. Next, let's take a look at some definite integrals. Now, our steps are going to be almost exactly the same, but we've got limits of integration. So I'm going to add on one more step, and that's finding those limits of integration also in terms of u. Otherwise, though, our steps are going to be the same, starting with that innermost function. So I recognize I've got a layering of functions there with the x squared plus 2x all to the 5th. So my u, if you guessed it, you were right, is an x squared plus 2x. I also need my du, just continuing with those same steps. The derivative is going to be a 2x plus 2. I'm going to follow all of that with a dx, but I really wanted an x plus 1. So let's go ahead and factor a 2 out in front, or you can think of that as dividing both sides by a 2. I end up with 1/2 du. Is going to replace now, that's going to be a 1x, so x plus 1 dx. So I've got my substitution for my x plus 1 dx, and I've got my substitution for u, but next I've got that last step, and that's to replace those limits of integration. Now, my limits of integration were 0 to 1, but these were in terms of x. I need to change both of these in terms of u. So I need to do u of 1. But if I go up to that formula for u, it is x squared plus 2. So I'm going to plug a 1 in there. X squared plus 2x, I meant. So it's going to be 1 squared plus 2 times 1. 1 squared plus 2 is going to be a 3. And that's going to give me my new under u, my new upper limit of integration, which is going to be a 3. Let's do the same thing to our lower limit. I need to change this to a u using u's formula, which is going to be x squared plus 2x. So 0 squared plus 2 times 0. This is equal to, it's a bunch of zeros. That's equal to 0. So my new lower limit in terms of u is equal to 0. Now you can leave these in terms of x. You would just need that step to go back to everything in terms of x. This is my favorite method. Everything's in terms of u, and I can just work through the rest of my integral. Okay, so I think I am there. Let's go ahead and replace everything inside that integral, including the limits, to write our integral now in terms of u. So my limits are now going to go from 0 to 3. x plus 1 gets replaced with a 1/2 du. I'm going to write that there. And then I've got x squared plus 2x to the 5th. That's going to be my u to the 5th. It's actually going to turn out really nice. Let me go ahead and just clean this up just a little bit by pulling that 1/2 out in front. 0 to 3 u to the 5th du, and I'm ready for that power rule for integrals. So I'm going to raise that power to the 6th power and then multiply by the reciprocal 1/6, and I get a u to the 6th evaluated from 0 to 3. So what we really end up with here is a 1/12. So I've got 1/12, and then that u to the 6th. I'm going to use my fundamental theorem of calculus part 2. Antiderivative at 3 minus antiderivative at 0. So I end up with u to the 6th. That's going to be 3 to the 6th minus 0 to the 6th. So into my calculator, I'm going to put 3 to the 6th divided by 12. Then I'm going to convert that to a fraction, and I get 243 over 4, and that's our answer, 243 over 4. We didn't need to go back to x's because this one had limits of integration. I'm going to write this one just a little bit differently, but I want you to see if you can recognize what your u is going to be. I'm going to write this as cosine x with a power 3 on the outside, and then a sine x, and then a dx. It's really easy when I write it in this form. I can see that that innermost function is my cosine of x. This is going to be my u. So u is equal to the cosine of x. I also need du. Du is equal to the derivative of cosine is negative sine x dx. But up here, I just have a sine x dx. So let's move that negative to the other side. So I really want negative du to replace the sine x and the dx. So now I've got both of my formulas here. So I've got one for u. I'm going to use this for my new limits of integration. And I also have one here for du. Okay, step number 3 is to find the new u values for the limits of integration. Right now, it's going to go from 0 to pi halves, but these are in terms of x. I want to have these in terms of u instead. So I need to take u of pi halves. Well, my function u is right here, and it's the cosine of x. So this is going to be the cosine of pi halves. If you're thinking about that unit circle, pi halves is straight up here, so I end up with a cosine of 0. So this is equal to 0. So as my new upper limit of integration, u is equal to 0. Let's do the lower limit of integration, u of 0. So this is going to be my u formula, which is cosine of x. So cosine of 0. Again, on my unit circle, I'm right here. So that's going to give me a value of 1. So that lower limit of integration is 1. They're backwards, right? Usually the low number goes on the bottom. I can swap these around with a negative sign, but let me do the substitution first, then we'll go ahead and swap things around. So as I do my substitution, everything in terms now of u. My limits of integration are 0 to 1. I had cosine of x cubed, but cosine is replaced with u. And then I had sine x dx, but sine x dx is replaced with a negative du. Now I can do a couple of things. I really want to swap this limit of integration here. As I swap it, I get a negative sign. That's going to be from 0 to 1. So going in the reverse order, remember these are directed areas. So I end up with negative integral from 0 to 1. But I also had this negative with the du. Let's bring this guy out in front as well. So we end up with those two negatives, which is going to make it positive. So in the end, we actually end up with a super nice integral. The integral from 0 to 1 of u cubed du. U cubed, I can use a power rule. Power goes up to 4, and I get a 1/4 out in front. So u to the 4th. I'm going to evaluate that from 0 to 1. So we have 1/4 Using my fundamental theorem of calculus, 1 to the 4th minus 0 to the 4th. 1 to the 4th is just 1, and we end up with our answer of 1/4. Now, sometimes U-subs are used in a slightly different way. Take a look at this video here, but you're doing great.